This is Ionic Bonds and correlates with Chapter 6.2 in your textbook. Your key concepts for this video are: how do ions form? What are the properties of ionic compounds? How are the formulas and names of ionic compounds written? So first off, let's talk about how ions form. You know that atoms are neutral, meaning they have the same number of protons and electrons, so the positives balance out the negatives. Well, an ion is a charged, or a positive or negative, atom. Atoms become charged, so they become ions, through gaining or losing valence electrons. So let's look at this closer. We have lithium here. We know its atomic number 3, so it has 3 protons and 3 electrons. One of those electrons is a valence electron because it's in group 1. Well, atoms like to have full valence shells, so lithium either needs to get rid of this 1 valence electron and drop down to 1 electron shell, or it needs to gain 7 electrons to fill its second electron shell. It's easier to get rid of one thing than to find 7, so lithium gives up its 1 valence electron. This means that now instead of 3 electrons, it has 2. So lithium has 1 extra positive proton, which gives it a positive 1 charge. This means it's a positive ion, meaning a cat ion, like meow. They're often formed by metals. Now in contrast, we have fluorine here. Its atomic number 9, so there are 9 protons and 9 electrons. It's in group 17, so 7 of those electrons are valence electrons. It also wants a full valence shell, so it either can gain 1 or lose 7. It's easier to gain 1, and lithium happens to have given up an electron. So fluorine takes that extra electron, and now fluorine has 10 electrons instead of 9. That 1 extra negative electron gives fluorine a negative 1 charge. This makes it a negative ion, or an anion, like antonym. These are generally formed by nonmetals. Now I keep saying they're generally formed by metals and nonmetals, but ions can also be formed by a thing called polyatomic ions. Poly meaning many, atomic meaning atom. So these are ions formed from more than one atom. They happen because of polar covalent bonds, but we'll look at that closer in the next video notes. If you look on page 220 of your textbook, you'll see a chart of common polyatomic ions. I want to talk about 5 of them. So ammonium here is a positive 1 cat ion. Ammonium is used in a lot of fertilizers. We've got bicarbonate and nitrate. These are negative 1 anions, so negative ions. Bicarbonate is part of baking soda, and nitrate is part of vegetables or for curing meats. You've also got carbonate and sulfate. These are negative 2 anions, so negative 2 charge. Carbonate's in soda ash and is used for making plastics and glass, and sulfates are found in a lot of shampoos as well as Epsom salts. So ions, any type of ion, will form an ionic compound. These form when oppositely charged ions bond. And just like magnets, they must have opposite charges because those attract together to form an ionic bond. You can see here we have a positive sodium ion, or a cat ion, and it's attracting to the negative chlorine ion, or an anion, to form sodium chloride, or table salt. Now you'll notice that in general, ionic bonds form between metals and nonmetals. This is really important. Please remember that. So let's talk about 3 important properties of ionic compounds. One is they form hard, brittle crystals. So most ionic compounds form crystalline solids. They also have high melting points. Table salt has a melting point of 801 degrees Celsius, where in contrast, sugar, which is a covalent bond we'll study in 6.3, has a melting point of 186 degrees Celsius. That's a huge difference. They also conduct electricity when dissolved in water or melted. Pure water does not conduct electricity very well. It's an insulator, whereas salt water is an excellent conductor of electricity because those ions allow for the electrons to flow. Now, you might be wondering why the names of ionic compounds like lithium fluoride and sodium chloride sound a bit different than some of the elements we see on the periodic table. So let's talk about how to name ionic compounds. First off, you would write the positive ion, which is often the metal, first. In this case, sodium. Then, second, you would write the negative ion, which is often that nonmetal, so in this case, chlorine. Then, you would change the ending of that second negative ion to "ide." So instead of sodium chlorine, we have sodium chloride. Now, if you're having your anion or your negative ion be a polyatomic ion, it will end in "ite" or "ate," depending on the ion. Now that you know how to name them, let's talk about how to write those ionic compounds' chemical formulas. To do this, first write your chemical symbol and put the charge of the ion as a superscript, meaning above. Then, write your chemical symbol for your anion and write the charge above. What you're then going to do is you're going to crisscross these numbers. So the 1 of fluorine goes down next to the aluminum, and the 3 of aluminum goes down next to fluorine. This gives us Al1F3. But you know that in chemical formulas, we don't have to write the 1, they're just implied. So our final chemical formula is AlF3, so aluminum fluoride. This means that it takes 1 aluminum atom to balance out the charges of 3 fluorine ions. We can also do this with our polyatomic ions. So here we've got magnesium sulfate. So we've got our magnesium ion with its +2 charge and our sulfate polyatomic ion with its -2 charge. We crisscross those numbers and end up with Mg2SO4 in parentheses with a 2. We put it in parentheses so we don't confuse these subscripts. Because these subscripts are the same, we can actually cancel them out, so our final chemical formula is MgSO4, meaning 1 magnesium ion balances out 1 sulfate polyatomic ion. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.